In this video, I'm going to explain all the main concepts of Helm so that you're able to use it in your own projects. Also, Helm changes a lot from version to version, so understanding the basic common principles and more importantly its use cases to when and why we use Helm will make it easier for you to use it in practice no matter which version you choose. So the topics I'm going to go through in this video are Helm and Helm charts, what they are, how to use them, and in which scenarios they're used. So what is Helm? Helm has a couple of main features that it's used for. The first one is as a package manager for Kubernetes. So you can think of it as apt, yum, or homebrew for Kubernetes. So it's a convenient way for packaging collections of Kubernetes YAML files and distributing them in public and private registry. Now, these definitions may sound a bit abstract, so let's break them down with specific examples. So let's say you have deployed your application in Kubernetes cluster, and you want to deploy Elasticsearch additionally in your cluster that your application will use to collect its logs. In order to deploy Elasticstack in your Kubernetes cluster, you would need a couple of Kubernetes components. So you would need a stateful set, which is for stateful applications like databases. You would need a config map with external configuration. You would need a secret where some credentials and secret data are stored. You would need to create the Kubernetes user with its respective permissions and also create a couple of services. Now, if you were to create all of these files manually by searching for each one of them separately on internet, it will be a tedious job. And until you have all these YAML files collected and tested and tried out, it might take some time. And since Elasticstack deployment is pretty much the standard across all clusters, other people will probably have to go through the same. So it made perfect sense that someone created these YAML files once and packaged them up and made it available somewhere so that other people who also use the same kind of deployment could use them in their Kubernetes cluster. And that bundle of YAML files is called Helm chart. So using Helm, you can create your own Helm charts or bundles of those YAML files and push them to some Helm repository to make it available for others. Or you can consume, so you can download and use existing Helm charts that other people pushed and made available in different repositories. So commonly used deployments like database applications, Elasticsearch, MongoDB, MySQL, or monitoring applications like Prometheus that all have this kind of complex setup, all have charts available in some Helm repository. So using a simple Helm install chart name command, you can reuse the configuration that someone else has already made without additional effort. And sometimes that someone is even the company that created the application. And this functionality of sharing charts that became pretty widely used actually was one of the contributors to why Helm became so popular compared to its alternative tools. So now if you have a cluster and you need to deploy a third-party application, you can actually look it up either using the command line. So you can do Helm search followed by a keyword of the application or service that you are searching, or you can go to Helm's own public repository at Artifact Hub or other repositories that are available and search for that application or service there. Now, apart from those public registries for Helm charts, there are also private registries because when companies started creating those charts, they also started distributing them among or internally in the organization. So it made perfect sense to create registries to share those charts within the organization and not publicly. So there are a couple of tools out there that are used as Helm chart private repositories as well. Another functionality of Helm is that it's a templating engine. So what does that actually mean? Imagine you have an application that is made up of multiple microservices and you're deploying all of them in your Kubernetes cluster. And deployment and service of each of those microservices are pretty much the same with the only difference that the application name and version are different, or the Docker image name and version tags are different. So without Helm, you would write separate YAML files, configuration files for each of those microservices. So you would have multiple deployment service files where each one has its own application name and version defined. But since the only difference between those YAML files are just a couple of lines or a couple of values, using Helm, what you can do is that you can define a common blueprint for all the microservices, and the values that are dynamic or the values that are going to change replace by placeholders. And that would be a template file. So the template file would look something like this. You would have a template file which is standard YAML, but instead of values, in some places you would have the syntax, which means that you're taking a value from external configuration. And that external configuration, if you see the syntax here, .values, that external configuration comes from an additional YAML file, which is called values.yaml. And here you can define all those values that you're gonna use in that template file. So for example, here, those 4 values are defined in a values YAML file. And what .values is, it's an object that is being created based on the values that are supplied via values YAML file and also through a command line using -- set flag. So whichever way you define those additional values, they're combined and put together in .values object that you can then use in those template files to get the values out. So now instead of having YAML files for each microservice, you just have one, and you can simply replace those values dynamically. And this is especially practical when you're using continuous delivery, continuous integration for your application, because what you can do is that in your build pipeline, you can use those template YAML files and replace the values on the fly before deploying them. Another use case where you can use the Helm features, package manager, and templating engine is when you deploy the same set of applications across different Kubernetes clusters. So consider a use case where you have your microservice application that you want to deploy on development, staging, and production clusters. So instead of deploying the individual YAML files separately in each cluster, you can package them up to make your own application chart that will have all the necessary YAML files that particular deployment needs, and then you can use them to redeploy the same application in different Kubernetes cluster environments using one command, which can also make the whole deployment process easier. So now that you know what Helm charts are used for, let's actually look at an example Helm chart structure to have a better understanding. So typically, chart is made up of such a directory structure. So it would have the top level will be the name of the chart, and inside the directory you would have following. So chart.yaml is basically a file that contains all the meta information about the chart. Could be name and version, maybe list of dependencies, etc. Values.yaml that I mentioned before is a place where all the values are configured for the template files. And this will actually be the default values that you can override later. The charts directory will have chart dependencies inside, meaning that if this chart depends on other charts, then those chart dependencies will be stored here. And templates folder is basically where the template files are stored. So when you execute Helm install command to actually deploy those YAML files into Kubernetes, the template files from here will be filled with the values from values.yaml, producing valid Kubernetes manifest that can then be deployed into Kubernetes. And optionally, you can have some other files in this folder, like a README or a license file, etc. So to have a better understanding of how values are injected into Helm templates, consider that in values.yaml, which is a default value configuration, you have following 3 values: image name, port, and version. And as I mentioned, the default values that are defined here can be overridden in a couple of different ways. One way is that when executing Helm install command, you can provide an alternative values YAML file using values flag. So for example, if values YAML file will have following three values, which are image name, port, and version, you can define your own values YAML file called myvalues.yaml, and you can override one of those values, or you can even add some new attributes there. And those two will be merged, which will result into a .values object that will look like this. So it would have image name and port from values.yaml and the one that you overrode with your own values file. Alternatively, you can also provide additional individual values using set flag, where you can define the values directly on the command line. But of course, it's more organized and better manageable to have files where you store all those values instead of just providing them on the command line. Another feature of Helm is release management, which is managed by the Helm binary. So the way release management with Helm works is by using the Helm upgrade and rollback commands. If an update to a Helm chart is released, or if you need to change the configuration of your deployment, you can run Helm upgrade. When you run Helm upgrade followed by the chart name, any changes made since the installation of the last release are going to be applied instead of simply removing it and creating a new one. And also, in case the upgrade goes wrong, for example, if some YAML files were false or some of the configuration was wrong, you can roll back that upgrade using the Helm rollback command with the chart name. You can roll back to the specific release version of the chart if you add the release version to the rollback command as well. The release version starts at 1, and each time you run Helm install, Helm upgrade, or Helm rollback command, this release version number increases by 1. So using this versioning system, you basically roll back to the version you require using Helm rollback.